Okay, ladies and gentlemen. So the answer ended up being 3.3. We're going to go ahead and move on to exponents now. So turn in your journal to page 8 or page 9 and 10. I don't care which. Page 8 is the foldable. Page 9 and 10 are our notes. They're both going to have the same content. So we have 6 rules of exponents. 6 rules. Now, common sense question. When are you allowed to use the exponent rules?
Whenever they apply.
How do you know they apply? Because the problem has exponents. Okay. My point is, don't use the exponent rules if you're not using them on exponents. Okay. I know that sounds silly, but it has been done before. Our first rule is the rule of multiplication. Whoa. The rule of multiplication. Okay? The rule of multiplication, actually, I'm going to pause, time out for a second. Before we talk about the rules, let's go over our vocab for a second. What's this big number called?
The whole number.
The base. This is called the base. What's the little number called?
Exponent.
Exponent. And the whole thing is called the power. All right, I'm going to be using those 3 words. Make sure you're comfortable with them. Base, exponent, power. All right, the rule of multiplication says that if you are multiplying 2 powers, I've got 2 powers here, that have the same base, the base is 3, that you can do what with the exponents? Add them. We can add the exponents. That's the rule of multiplication. So 4 plus 2 is
6.
6. 3 to the power of 6. Notice that the base has stayed the same, it stayed at 3. Now, if I wanted to show my work on this, I could write this out in expanded form. This first part is 3 times 3 times 3 times 3, right? 4 3s. 3 times 3 times 3 times 3. Then the multiplication right here would go in the middle. And then this is 3 times 3. Now, how many 3s do I have total? 6 3s. All right, that is the proof. This is why that you can add them together. We would end up with 6 3s. Okay? Good? All right, next rule. Next rule is the rule of division. The rule of division says that if you are dividing 2 powers that have the same base, this one has a base of 6, you can subtract the exponents. So this is going to be 5 minus 2, which is 3. So 6 to the power of 3. Again, we can prove that by writing this out in expanded form. We're going to have 5 6s on top and 2 6s on bottom. And these 6s will just simply cancel out. 6 divided by 6 cancels. And now we're left with 3 6s on top. We good with that? All right, so the rule of multiplication says you add the exponents. The rule of division says you subtract the exponents. The next one is the rule of
0.
Good. Look at y'all. Y'all are so smart. I can't even. OMG, I can't even. The rule of the 0 exponent says that if you ever end with 0 as the exponent, the answer is automatically 1. Very good. And we can prove this. Again, let's say we had 8 to the power of 2 divided by 8 to the power of 2. Well, we would use our rule of division and subtract 2 minus 2, which equals 0. Okay, keep that in mind as we write this out in expanded form. 8 times 8 over 8 times 8. The 8s are going to cancel out. And so what am I left with?
0.
No.
1.
1. Because 8 divided by 8 isn't 0, it's 1. Okay? We good with that? A common mistake, do not make this mistake. If you get this part right here and you figure out that it's 8 to the power of 0 and you know that 0 equals 1, do not do this. 8 to the power of 1. That's wrong. Don't change your exponent to 1. The exponent is 0. Change the whole number to 1. Got it? Okay, good. The rule of multiplication says what? Add. The rule of division says what?
Subtract.
The rule of zero exponent says
1.
it equals 1. Next one is the rule of negative exponents. Good. So if you ever end with a negative exponent, we're going to turn it into a fraction with a 1 on top if you don't have anything else. And on bottom is going to be this power, except
Positive.
it's positive now. Because that's the point of turning it into a fraction, is so that it's not negative anymore. We can prove this as well. Let's say we had 7 to the power of 3 over 7 to the power of 5. Now, this is a division problem, so what will we do here? Subtract. Now, this isn't 5 minus 3. This is 3 minus 5. 3 minus 5 is negative 2. So keep that in mind as we write this out in expanded form. Okay? Expanded form would be 3 7s on top. 5 7s on bottom, and the 7s would cancel. And what am I left with up there? 2 7s, but are they on top or on bottom?
Bottom.
They're on bottom, which is why we have a fraction with a 1 on top, and the 7s are on bottom. Okay? That was rule 4. Rule number 5 is power to a power. Now, for these last two, they both have parentheses. They both have parentheses, so don't get them mixed up. So what we have here is we have a power inside parentheses, and then it's raised to another exponent. So an exponent on top of an exponent. Do we remember what to do here? Multiply what? The exponents. This would be 2 times 3, which is 6. And so we're going to have 4 to the power of 6. Again, I could prove this. We can write everything that's inside the parentheses, which is 4 times 4. And I'm going to write that 3 times. One, two, three, four, five, 6 fours. Okay? And last rule. Product to a power, which, by the way, guys, is interchangeable with quotient to a power. They're basically the same rule. So if you see both of them on your paper, it's because we combined these two together. You're going to do the same thing, whether it's product, meaning multiplication, or quotient, meaning division. It's going to be the same rule that happens. Now, this one's got parentheses as well. What is different from these parentheses to these parentheses? Okay, it does have a variable, you're correct, but I'm not worried about the variable. Something else. Okay, it's where the exponent is part of it. This one's got 2 exponents, and that one has 1 exponent. What about the base? How many bases does this one have? 2 bases on this one. That's where you're going to see the difference, okay? If it's got 2 bases, that means it's product to a power or quotient to a power. So what I'm going to do here is I'm going to take the exponent that's outside of the parentheses, and it's going to, like distributive property, go to both of what's inside the parentheses. So we're going to end up with 3 squared and x squared. Okay? Now that one is product to a power. Quotient to the power would be the exact same thing, except for it would be in a division problem to start with. Okay? The 2 would still go to both of the bases. Question. Why can I not use the rule of division on this division problem? Not because they only have 1 exponent.
Because they both don't.
No. Not exponent. Doesn't have to do with the
Two
exponent.
bases.
What about the base? What was the base on this other one?
It's not the same base.
It was the same. The base was same over here. On this one, we don't have the same base. So we can't use an exponent rule if it doesn't have the same base. Okay? All right. So, first rule of multiplication says to what? Add. Second rule, division says to subtract. Third rule, 0 says it equals 1. The rule of negative says fraction. Power to a power, you're going to multiply the exponents, and product or quotient to a power is like distributive property. All right, those are your exponent rules. We are now going to have a few examples. So, you do not have to show your work, and you do not have to write the question because we only have 10 minutes left. You just have to write your answer, and you have to say what rule you use to find the answer. I will be drawing sticks. There you go. That's the first one.